Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. During the on-site commissioning of power transformers, a set of tests are performed to confirm that the power transformer can be put into service. In this episode of Energy Talks, OMICRON field testing experts Bernhard Engstler and Marcus Stenner talk about their practical experiences with the on-site commissioning of power transformers. Bernhard and Marcus recommend which tests should be performed on power transformers to check a variety of parameters during commissioning. They also describe how the test results are reported and how to make on-site commissioning more efficient. Hello, Bernhard. Welcome to Energy Talks.
Hey, welcome, Scott. Nice to be here.
Marcus, also a big welcome to this episode of Energy Talks.
Yeah, hi. Warm welcome from my side, Bernhard and Scott.
It's great to have you both here for this discussion. My question for both of you is, what is your experience and how long have each of you been involved with the on-site commissioning of power transformers? Bernhard, let me start with you. What area of power transformer testing have you been most involved with?
Well, I've been testing power transformers for about 9 years. And strictly speaking, it's not just commissioning, but diagnostic tests in general. So primary testing of power transformers, which include tests which are just a small part of the commissioning process. But the diagnostics aspect brings an interesting perspective because you know if a transformer fails during its lifetime, which fingerprints you would like to have, and therefore you know which tests are required or recommended for during the commissioning or on-site test, or let's say site acceptance test. And the areas which I've been working on is basically the whole range of electric and dielectric tests, such as tangent delta or power factor tests, sweep frequency response analysis, and the basic electrical tests like winding resistance, ratio, or tap changer diagnostics.
Okay, very good. Marcus, what has been your experience?
Yeah, I'm working for OMICRON as a commissioning engineer since 2004. And with regard to Bernhard, I have less experience in the diagnostic of transformers. My job starts when all cables between the transformer and the control, monitoring, and protection system are installed and ready for commissioning.
Okay. What role does commissioning play in the service life of power transformers? Why is it important? Bernhard, what is your opinion?
Well, on one hand, obviously, it's to ensure that the transformer survived the transport without suffering damages. Now, speaking from my perspective, doing primary tests, and that no problems have been introduced during assembly of components and during installation. On the other hand, the site acceptance test is a valuable fingerprint for further diagnostic tests and trending, as some of these parameters can change during the lifetime of a transformer.
Okay. Could you help me understand what you mean by a fingerprint?
Yeah, a fingerprint is basically a baseline measurement. So it's your reference whenever you do a test in the future. You can compare results to this fingerprint measurement, and it's the easiest way to detect problems or deviations from when the transformer was known to be in a good condition. There are other ways to do it, which require more experience and knowledge, but fingerprint measurement is basically the best or the go-to solution to compare future measurements.
Okay, thank you. Marcus, what is your opinion about how commissioning plays an important role in the service life of power transformers?
Yeah, for me, a proper carried out commissioning is important to reduce the likelihood that the transformer has hidden malfunctions during the whole life cycle of a transformer, to avoid a blackout in the system.
Okay. Which types of tests are performed on power transformers during commissioning? Bernhard, which tests are you most involved with? You had mentioned diagnostic tests.
Yeah, one pretty standard test nowadays is the sweep frequency response analysis, in abbreviation SFRA. And that is done to ensure that the transformer did not suffer damage during transport because of shocks or vibrations when loading or unloading the transformer or during the transport itself. So what the manufacturer is doing, he's doing an SFRA test. That's basically a frequency response where the windings are tested across a wide range of frequencies. And after transport, that test is done again and both measurements are compared. And if there are any deviations between them, it tells you the likelihood of a mechanical problem or geometric shift that may have been caused by shocks or vibrations during transport. So that is one typical test. Then also the winding resistance test is quite typical. Especially if, for example, bushings are disassembled for transport because they are way too big to have the transformer transported on a railway or on the street. Then they have to be reinstalled on site. And with the winding resistance test, you ensure that all the connections have been done properly. If there is a bad connection, the resistance would increase, and that would lead, for example, to hotspots during operation or even a failure during switch on. So that's another test which is quite typical and highly recommended.
Mm-hmm.
And finally, among a long list of tests, of course, that's not a complete list, but the capacitance and tan delta is also quite important, especially for bushings. The capacitance is a quite important parameter to trend or monitor over the lifetime of bushings. And if capacitive layers suffer damage or are shorted, this shows in the capacitance measurement. And while the manufacturer also does this measurement on the bushing on its own, these capacitance values change when they are mounted in the transformer. So the site acceptance test is basically, again, the baseline for future diagnostic tests.
So the tests that you mentioned that are most important, how long do each of these tests take to perform?
That's a question which cannot easily be answered because that depends very much on the size of the transformer. I mean, this can take anything from half a day to 2 days, also depending on the requirements and tests which have to be done. So it's a completely different thing doing a test on a 40 MVA transformer than doing the same measurement procedure on, let's say, a 500 MVA transformer or a three-phase transformer bank with 3 individual poles. And then it depends on the requirements. And also many times the utilities have a specific list of primary tests which they want to be performed. So unfortunately, there's no answer which corresponds to all circumstances.
Okay. Which diagnostic equipment is used to perform each of these tests?
For the basic electrical and electrical tests, it's the Testrano 600 and CPTD. It's an equipment which is dedicated for a series of basic tests. And for SFRA, there's a different device, the Fresnel 800, for example. And with this equipment, you can cover most of the required tests on site for site acceptance.
Okay, so that brings up a point. So for some of these tests, can you conduct them with one testing solution, or are separate devices required?
Yeah, the SFRA measurement requires a separate device, but all the other tests can be done basically with the Testrano and the CPTD. So that's a combination of devices which cover a wide range of tests, or the most common ones. Yeah.
So you mentioned before when I asked you how long do these tests take, some of these tests which you can perform with one device, that certainly is a time savings, would you say?
That's a big time saver. Historically, there have been devices for each of these tests, like one ratio tester, one winding resistance tester, and so on. And all of these tests are now possible with the Testrano 600.
Mm-hmm.
And furthermore, most of these tests can be done with one single connection. So you save a lot of time by not having to rewire for each test. But most of them can be done with one wiring. You execute a test after the other. No need to climb the transformer or go up and down with a man lift.
Mm-hmm.
So that is a big time saver. And of course, less wiring faults can be introduced. because you have to do less rewiring. And the safety aspect as well is there, with less climbing, less going up and down.
Okay. Bernhard, thank you. Marcus, what other tests are important to perform on power transformers during commissioning?
So normally when Bernhard is ready with the diagnostics tests, I'm starting first with the tightening test of all wires, cables, and connections to make sure that there are no miswiring or open connections, and they have to search during the commissioning so that everything is proper connected.
Mm-hmm.
And after that, I continue with the functional test by release functions from the train to the source. For instance, when you have the Buchholz relay, I push the button first slowly to get the gas alarm. And then I push it fast and I got the pressure alarm. And that means I also trip the circuit breaker. So I can have a look on the indications at the local control. And with the pressure, I can check if all circuit breakers which are connected to the transformer are tripped in each voltage level. Another example is the modular temperature measurement for the system for warning and controlling of the fan groups of the complete cooling system.
Mm-hmm.
Or testing voltage regulators, the voltage regulator as a secondary device in combination with the tap changer. It's important to do these tests. Additionally, normally I have to test the CT and VTs from the source to the drain. And when all these auxiliary systems are working, for me, these are auxiliary systems, I start with the protection testing.
Mm-hmm.
And typically I start, and this is highly recommended by the customers, I start with a stability test of the protection device by injecting secondary values to the protection. Mm-hmm. And I also test the tripping characteristic and the tripping times of the protection relay. Since 2 years now, we are able to do some tests with a relay sim test with a model of the transformer. And there we are able now to do some system tests, which includes inrush, sympathetic inrush, or high short circuit currents externally of the protection zone with and without CT saturation. We can see how is the transient behavior of the protection system and how does it work together. That's a big benefit for the protection testing.
Okay. Now, which diagnostic equipment or equipment are you using to perform these tests?
Yeah, normally I'm using for the CT and VT tests, I use this CT analyzer and the Votano. And for protection testing, I mainly use the CMC 356.
Okay. So how long does it take for you to perform these other tests?
Yeah, I think I have the same answer as Bernhard. It's highly depending on how faults were found. So is there still incorrect wiring? Are the settings correct? Did I some connections wrong? So I could not really say. It depends on the size of the transformer and how many auxiliary systems are installed there.
Are there any challenges with performing on-site commissioning, and how are these challenges solved? Bernhard, what is your opinion?
I would say there's always challenges, and one of the challenges is certainly to coordinate with all the different parties working on a commissioning project and ensuring that everything is ready for my part, which I'm doing. So, for example, it is nice to have a power supply for the onload tap changer. Otherwise, when you do winding resistance on all the taps, you have to crank it manually, which needs a lot of time and effort. And on bigger transformers, you have to organize a man lift. So you have to make sure that all the auxiliary things are there for testing. And you typically don't have that much of a time frame to do all these tests. So it has to be well coordinated. And also ensure that while you're doing primary tests, nobody is around. Fence off the area for safety reasons, because sometimes there are higher voltages applied to the transformer and you have to make sure that nobody is in the dangerous area. And also you have to ensure that voltages are not carried to other systems where you might not expect them, and ensure that all the parties, well, keep their fingers away from all the systems of the transformer, which could be under voltage.
Okay. Marcus, do you have anything to add?
Yeah, for me also, the work safe topic is really important. During commissioning, a lot of different companies are working in the substation. Therefore, it's very important to know who is doing what, where, and when, and it needs to be coordinated. Another thing is during commissioning, it's highly depending on the weather conditions. If you can test or not test, for example, humidity can distort the results. And that can have a big influence. And for me, it's good to have an automated and prepared test file to schedule the test and to have some spare time for unforeseeable disturbances like the weather or some miswiring.
Good point.
Yeah, and I want to jump in on one point regarding preparation.
Sure.
That is also quite important for primary tests. Again, for smaller transformers, standard test leads might be sufficient. The bigger the transformer gets, or especially transformer banks, you have to know the dimensions. So width, height, depth, in order to make sure that the test leads are of sufficient length, because they can become quite long. From the experience I made with transformer banks, you need sometimes up to 30 meters of test leads. And you want to make sure that you have this information beforehand so you can take everything with you.
How is the testing data gathered, analyzed, and reported? Bernhard, for the tests you described earlier, how is this handled?
Typically, I use our software Primary Test Manager for primary tests on the transformer. And this allows to prepare all the tests beforehand if the transformer data is already available, which I typically request beforehand. And that allows to set up these tests and start testing and not having to enter all the transformer data on site to save time. And basic analysis can be done already in Primary Test Manager because there's some basic assessment criteria which you can use, and it gives you an assessment, pass, fail for most of these tests. It's also a good idea to have factory tests on hand if results are not as you expect, to have a direct comparison. And the reporting then can also be done in PTM. So you can configure your report, what you want to have included and what not. Do you want certain graphs included? And you can export that report with measurement results and graphs as PDF or Microsoft Word or Excel. So that's basically with one click of a button to create these reports.
Okay, so even though you are performing some of the tests with different types of equipment, you have one software that works with all of them.
Exactly, yeah. So, for example, the Testrano 600 tests, power factor tests, winding resistance, and even SFRA, that's all controlled from within PTM. And so the test report can also be generated, including all of these tests.
Okay. Marcus, how is this performed with the tests you mentioned?
Very often I have to use the report templates of our customers to fulfill their requirements. But additionally, we normally hand over the different test reports, which are made in the test universe, OCC, OMICRON Control Center, or in the Relay Sim test reports as a PDF or as a test file itself, where you have the indication if the test fails or passed. And that's a good way to do it.
Okay. How do substation operators use this data to confirm that the power transformer can be put into service? Bernhard, what is your opinion?
Well, it's mostly by comparing these test results, which are done during the on-site test or site acceptance test, with factory tests. So that's relatively easy. Other tests have simple pass-fail criteria because they are well defined in standards. And for SFRA measurements, it's crucial to compare the measurement data on site with the factory test. And for this comparison, PTM offers a lot of functionality in terms of import formats. So whatever device the manufacturer has used, you can usually import these measurements directly into PTM and then compare these factory tests with the on-site tests and come to a conclusion if this test has passed or failed. And there's also some automatic assessment functions there.
Okay. Marcus, what do you think?
Yeah, most of the operators are checking the final test report and compare these results with a comparative test. The most time they're also doing a cross-check with the requirements which are mentioned in the internal documentation. And there they have some limits, so the tolerances are defined, and yeah, our tests have to be in the boundary of these tolerances, and then we have a pass and fail criteria, and then hopefully everything is working quite good.
Okay. Do you have any practical tips for our listeners to make the on-site commissioning of power transformers easier and more efficient? Bernhard, what do you suggest?
Prepare well. I think that's valid for all tests, but as I mentioned, know what transformer you have to test, get the nameplate data, get the dimensions, ensure that the coordination is okay with all the different parties involved in commissioning in general. Check if you have power or where you can get power for your test devices or for an on-load tap changer in case you're doing primary testing. And I mean, if you talk about efficiency, the devices you're using, of course, play a big role. As I mentioned, for example, the Testrano 600 makes it quite easy in terms of wiring, in terms of test speed, because it's a three-phase capability. And as I said, because a lot of things can be done with one single wiring, so that it makes it easier and more efficient.
Okay. Marcus, what are your recommendations?
If possible, follow your prepared workflow. And if there are other parties in the substation, don't hurry up because they told you hurry up. So it's very important to work safe. So follow your own rules and don't put the pressure on your shoulders. That's it.
Very good. Okay. Good advice. So after a successful on-site commissioning, how long does it take before you need to test again? Why are further tests needed? Bernhard, what do you suggest?
Well, that's a broad question, which is typically handled differently by different operators. So I can just tell you what I have seen, what utilities or operators, or some of them typically do. And they have a maintenance or test plan established with certain intervals. And there's also different philosophies like time-based maintenance or condition-based maintenance. So time-based means you do it at certain intervals, and condition-based means the intervals are defined by the condition of the transformer and is shortened if you suspect that there is a problem or there is a strong indication that there's something wrong. But generally, a lot of operators do transformer tests or primary tests in an interval of about 4 years. And then, as I said, depending on the condition of the transformer, may reduce or even increase these intervals.
Okay. Marcus, what is your suggestion?
The most of our customers perform the maintenance test in a cycle of 4 years up to now. But now they changed to a complete maintenance test. It could be all 6 years or all 8 years, but in between they have a functional test, which means that all analog values are checked, all tripping contacts are checked. And so they try to reduce the time for testing. And that's what's coming up now.
Bernhard, where can our listeners get more information about on-site power transformer commissioning?
We don't have particular information about commissioning of power transformers, but we have a lot of articles, for example, on our OMICRON magazine or YouTube videos about power transformer testing in general. So these tests that I've mentioned, which are typically done during the site acceptance test, they are all found on our YouTube channel, for example.
Or even on the OMICRON website under applications, correct?
Yeah, exactly. And of course, if we have academy trainings around these transformer tests. But as I said, it's not specifically for commissioning because a lot of these primary tests are done during site acceptance, but also then for diagnostic purpose after commissioning or just as a routine test after a certain period of time.
Okay, thank you, Bernhard. Marcus, do you have any suggestions about where our listeners can get more information about power transformer commissioning?
From the secondary side, we have the dedicated training courses for the different software modules and software systems where we perform the tests with. But we have now practical training, dedicated practical training for commissioning. But if you are interested in a special training, please let us know by posting in the comments.
Bernhard and Marcus, thank you both very much for sharing your knowledge and experiences with on-site power transformer commissioning in this episode of Energy Talks.
Thank you very much, Todd.
Yeah, most welcome.
Thank you both again. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing and offers you the matching solution for your application. This includes power transformer testing, which was the topic of this episode. For more information, be sure to visit our website at OMICRONenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.